I'm going to finish section 3 out of chapter 2. This is where we stopped last time. This is what's up next. Factoring a polynomial repeated division. So what I'm going to do is I'm going to take this polynomial right here and divide it by each of these two factors. Now these are factors of this polynomial. So when I divide by the factors, I'm going to use synthetic division. And when I divide by one of the factors, I'm going to take the answer and divide it by the next factor. So I'll start off with this. So again, we're using synthetic division, so I need to write down the coefficients of our polynomial. And again, remember, we're going to put in this box right here, whatever makes x equals, whatever makes a whole thing equals 0. So what does x have to be to make it equal 0? So again, this is what we're going to do. But obviously, it's going to be a positive 2. So we'll put a positive 2 right here. And then I'll divide. Remember, this last number right there is going to be our remainder. So using synthetic division, let's bring down the first number. And then we'll multiply 2 times 2 to get 4. Let's combine like terms right here. That gives us 11. Again, multiply 11 times 2 to get 22. Combine like terms, that gives us a positive 18. Multiply again, 18 times 2 is 36. Combine like terms, that gives us a positive 9. And then we'll multiply 9 times 2 to get positive 18. That gives us our 0, which is what we expect because x minus 2 is a factor. Then I'm going to take the answer. I don't need to plug my variables back in, although I do know this would be an x to the third, x squared, x to the first power, and this is my constant. But this time I'll divide by this factor. I know that's going to be a negative 3. Just bring the first number down. That gives us a 2. Let's multiply, you get negative 6. Combine, get 5. Multiply again, get negative 15. Combine to get 3. Multiply, get negative 9. And our remainder is 0. So again, this is a factor of this polynomial. Even though I didn't divide this factor into that polynomial, I did divide it into that polynomial, which is the third degree polynomial. So this is going to be a factor of that also. So what I have left now, I started with a fourth degree polynomial divided by a first degree polynomial, which gave me a third degree. I took the third degree and divided by a first degree. That gave me a second degree, which is a quadratic. So let's take that quadratic and let's go ahead and put our variables back in. 2x squared plus 5x plus 3. And let's factor it because we do want to find the remaining factors. Again, anytime we solve a polynomial function, this is basically the steps that we take. We haven't talked about how do we find these other factors that we start off with first, but once we do talk about it, this is what we're doing, going through the steps to take that fourth degree polynomial down to a second degree. All right, so factor in this quadratic, that gives me 2x squared. Let's go positive 3 right here. Let's multiply 2 times 3 to get 6. And let's find all the factors of 6. As I always say, this is my most important sign. That tells me two things. It will tell me what my signs are in there. They will both be the same. It will be the same as whatever that is, so they're both positive. And the other thing it tells me is that I will add to get 5. So the only factors that will add to get 5 is that 2 and 3. And I do know they're both positive. So positive 2x here and a positive 3x here. I can put the positive 3x here and a positive 2x. It doesn't matter where they go. All right, next step is go ahead and find our GCS for the first column. GCF first column is x. GCF second column, 1, positive 1, because they're both positive. GCF for first row is going to be 2x. GCF for the second row will be a positive 3. So we got it factored. X plus 1 and 3x. Sorry, not 3x, 2x plus 3. I'll change that 3 to a 2. Okay, so we found the remaining factors. The remaining factors is x plus 1 and 2x plus 3. Okay, I'm gonna, you can pause the video, you can work on that. All right, now that we're back, I'm not going to, we can talk about this later on, but I do want to go ahead and continue with the rational zero test. In the rational zero test, what that tells me is it tells me the possible rational zeros of a polynomial function. The possible. There's no guarantee that they are going to be a rational zero, but if we're looking for a rational zero, this is the list that we're going to use. All right, so the rational zeros consist of what? P and Q's. P represents the factors of the constant term, and Q represents the factor of the leading coefficient. So it's going to look something like this. Let's look at the next example. Okay, and here you go. You see that again. Possible rational zeros will be the factors of the constant term over the factors of the leading coefficient. So if I'm looking at example number 7, I see that I have a constant of 1. So, and this is a really very basic one, but that means P will be equal to only plus minus 1. Because think about this. Positive 1 will divide into 1. So positive 1 is a factor of 1. Negative 1 will also divide into a positive 1. So negative 1 is a factor. So each time you find a number that will divide into either the constant or the leading coefficient, then the positive and negative will be factors. Q would be the factors of the leading coefficient. My leading coefficient is 1. Remember, the polynomial needs to be written in descending order based off of its degree. So highest degree first, and then descends down to the constant. Again, my leading coefficient is a positive and a negative 1. Possible rational zeros consist of, more often than not, you're going to see a lot more numbers here and a lot more numbers here. It will be each one of these P values over each one of these Q values. Now, I only have 1 over 1. Positive 1 over positive 1, negative 1 over negative 1. So the possible rational zeros for this particular polynomial function will be either positive 1 or negative 1. So if you're looking for a rational zero for this particular problem, it's either going to be a positive 1 or a negative 1, or it could be both. I will do this one because we do have a little bit more to deal with here, because my constant is an 8 and my leading coefficient is a 1. So let's go ahead and find the factors of that 8, and that would be my P values. All the numbers that would divide into 8. Well, I know 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. There are no other numbers that will divide that would divide into 8 evenly. Q would be all the factors of the leading coefficient. My leading coefficient is a 1, so that's pretty simple. Plus minus 1. P over Q represents all of our possible rational zeros. So each one of these over that, there's only 1. So we're doing 1 over 1, which is 1, 2 over 1, 4 over 1, and 8 over 1. So this is a list of all the possible rational zeros I could have for this polynomial function. Again, we can't have all of them because there are 8 of them altogether, 8 of these, and I can only have 3, at most 3 of them could work. Okay, so let's take this a little bit further. All right, so using the rational zero test, what we want to do first of all, then this is the same thing again, but this time we have a leading coefficient of 2, and we have a constant of 3. So the only thing different is this. So P represents all of my factors of 3, so that would be a plus minus 1 and a plus minus 3. Those are the only numbers that will divide into 3. The factors of my leading coefficient. This time my leading coefficient is a 2, so plus minus 1 and plus minus 2. Again, P over Q represents all the possible rational zeros for this particular polynomial. We'll do each one of these over 1, so that would be plus minus 1 and plus minus 3, and then each one of these over 2. So plus minus 1/2 and plus minus 3/2. Okay, so again, those are 8 possible rational zeros for that function, and only at most 3 of them could work because this is a third-degree polynomial. All right, so this is the rational zero test, and we're going to do one more just to get the hang of this. We'll have a bit more here because my constant's a 30. I don't care, it's negative. My leading coefficient's 2. So all the factors that would divide into 30, plus minus 1. 2 won't do it. No, I'm sorry, 2 will do it. What am I thinking? 3 will do it. 4 won't. 5 will. 6 will. 10 will. 15 and 30. So we've got a lot more here that we're dealing with. My leading coefficient, all of its factors. Well, we've already done 2 once before. It's plus minus 1 and plus minus 2. Now let's do P over Q. So again, each one of these P values will be put over 1. So basically it's just that list again. And then each one of these over 2. So plus minus 1 over 2, 1/2. 2 over 2 is 1. I already have it. I don't need to write it again. 3 over 2. 5 over 2. 6 over 2 is equal to 3. I already have it. 10 over 2 is equal to 5. I already have it. 15 over 2 is next. And then 30 over 2 is 15. I already have it. So notice that the list gets larger because I have more P values to deal with, and then I have these Q values. But remember that I do not need to write one down more than once because maybe something reduced into something I already had. 10 over 2 reduced to a 5, so I didn't have to write 5 down twice. All right, so how do I tell which one of these? Now, this does ask, find the rational zeros of. This is the list I'm going to work with. So I need to have my calculator. And in my calculator, I will type in this function. I know you can't see that very well because that light was just blinding it. All right, so I'm just going to double check, make sure I typed in everything correctly. All right, so I have 2x to the 4th minus 9x to the 3rd minus 18x squared plus 71x minus 30. Perfect. Okay, now here's a trick with the calculator that I can do to help me go through this list quickly. I'm going to hit the second and the table set, the second window button. I will go down to where it says independent, and I will make sure that it says ask. I will move my cursor over to ask, hit enter on it, and make sure it's highlighted. So notice it's highlighted. Okay, so it's going to look, it'll look like that when you're done with it. Then go to my table, that will be second graph. And I already have a whole bunch of numbers in there, but that's okay. I'm going to type in each one of these numbers one at a time. 1, -1. Nope, neither one of those two work. 2. Oh, look at that. I got a 2. 2 is a factor of, 2 is a solution to this. That's because I get the 0. So x equals 2. Let me write that down. How about -2? Nope. All right, 3. Nope, -3. right, so -3 works. I type it in. Keep on going. 5. 5 works. Let me write it down. Let's type in a -5. Nope. 6. -6. 10. -10. 15. I'm getting the impression that none of these others will work. All right, no big deal. And then 30, -30. Okay, so find the rational zeros of that polynomial function. There they are.